Okay, good day. So let's have our new topic. So this is the integration involving inverse trigonometric functions. So we have here three equations or formulas for the integration of, for example, we have a du, then that is to be divided by a square root sign, then the difference of a constant squared, then minus a u squared. So let us take note that we have a, that is any value of a constant, or let's say a squared, then we have the u squared. The u squared is any function of x. Alright, so let's try to apply to one of our examples. So, for example, okay, so let us evaluate the integral of dx, that is to be divided by the square root of 9 minus x squared. So among this given equation, so which one will be applicable? So take note that we have a constant 9 minus x squared. So if you are to observe these three equations, this equation or the first one will be applicable. So this is similar to the integral of our du, that is divided by the square root of a squared minus the u squared. So we have what is the equivalent of our a. The value of a is equal to, or the value of a squared is equal to 9. If we are to take the square root both sides of the equation, simply the equivalent of a is equal to 3. And what will be the equivalent of our u squared? So u squared is simply equal to the x squared. Again, if we are to take the square root of both sides, we'll be having the equivalent of u is equal to x. So if we are to take the first derivative of u, again, that is obviously we have that as du, and that is equal to simply dx. So it satisfies the first equation. So therefore, this is simply equal to that is the arcsine. The arcsine of u divided by a plus c. So we are now ready to substitute. That is simply the arcsine of what is our u again. So the u is simply equal to x, then divided by a. So u is simply equal to x, and a is simply equal to 3, then plus c. So this will be our answer for our first example. Okay, so let's try another example. Okay, so this time, let's say, evaluate the integral of dx. That is to be divided by the square root of 5 minus 16 of x squared. Again, if we are to observe, we have that as dx, that is divided by the square root of 5, which is a constant, minus 16x squared. So from the given formulas, we have still the first formula will be applicable. So let's have the equivalents. The equivalence of our a and u. So the equivalent of our a, again, that is a squared is simply equal to 5. So 5 is not a perfect square, but that's not a problem. So let's take the square root, or the value of a is simply the square root of 5. Okay, then we have the equivalent of the u squared is equal to 16 of x squared. If we are to take the square root, both sides of the equation, so we'll be having, we'll be having that is the equivalent of our u is simply equal to 4 of x. If we are now to take the first derivative, that will be equal to du, then 4 of dx. Dividing both sides of the equation by 4, so we'll be having that as 1/4 of du is equal to the dx, so which is the numerator. So we'll be needing to place a correction factor. So a correction factor which is equal to 1/4. And then we are now ready to perform integration simply by, we are just to substitute this equivalence. So again, it satisfies the condition that is equal to the integral of our du, that is divided by the a squared minus the u squared, which is equal to, this is the arcsine of x divided by a plus the constant c. So let us perform integration. Again, don't forget our correction factor, which is equal to 1/4. So we have that as 1/4 multiplied by arcsine. What is the equivalent of our correction there? It should be arcsine of u. It's correction of u over a. So that is, again, we go back, 1/4 of arcsine. What is the equivalent of our u? The equivalent of u is simply equal to 4x. So we have that as 4x divided by the equivalent of a. The equivalent of a is simply equal to the square root of 5. So this is the square root of 5 then plus the constant c. So this will be our final answer for the second example. Okay, so let's try another example. Okay, so let's say we evaluate the integral of dx, that is to be divided by the square root of -7 minus 8x minus x squared. If we are to observe this given, this is not similar to any of the given formulas, but we can perform mathematical manipulation so that we can arrive with these terms, maybe. But for this one, the applicable formula is the first one, still on the arcsine of u over a plus c. All we have to do is, again, express these terms inside the square root sign or the radical sign, similar to this one. But as you can see, we have the term or the terms that is equal to -7 minus 8x minus x squared. So all terms are negative. We can factor out the -1 or the negative sign. So this is now equal to negative. Then we have 7, then plus 8x, then plus x squared. So we can do completing the square so that we will be having just 2 terms. So if you are to recall, we need to rearrange first the terms. So the first term will be the one with the highest exponent, that is x squared plus 8x. So that is the 8x. Plus 7. If you have to recall how to perform completing the square, so you have that as the negative x squared. All we have to do is observe the numerical coefficient of the x. So the numerical coefficient of x is 8. What is half of 8? The half of 8 is 4. If we are to square this one, 4 squared is equal to 16. So all we have to do is add 16, then plus 7. So take note that we are just adding 16, just to complete this square, the x squared plus 8x plus 16. But we need to subtract 16 from the constant 7. So basically, we did not add anything. So this term is still similar, or this expression is still similar to our original expression. Since again, if we are to cancel out, 16 minus 16 is still 0. So if we are now to simplify, we have that as the negative x squared plus 8x plus 16. So this is a complete square. Then 7 minus 16, that will be a negative 9. Okay, then we factor. So this is now equal to, again, the negative. So what is the equivalent factor of x squared plus 8x plus 16? That is the same as x plus 4 quantity squared, then minus 9. So again, x plus 4 quantity squared is the same as the x squared plus 8x plus 16. So that is the purpose of the completing of the squared. So we may again distribute the negative sign. That is equal to, okay, the negative quantity of x plus 4. Okay, this is quantity squared, then negative times negative 9, that is plus 9. So if we are now to rearrange again, that will be the same as the positive 9 minus the quantity x plus 4, okay, quantity squared. So basically we have, that is the negative 7 minus 8x minus x squared is basically equal to this expression. Okay, so that we can express our terms inside the radical sign to be 2 terms. So therefore, okay, we can rewrite this one as the integral of the dx, that is divided by the square root of, again, what is the equivalent of negative 7 minus 8x minus x squared is simply the 9 minus the quantity x plus 4, okay, quantity squared. So that is now similar or in the form, again, of our first formula. So this one. So therefore, again, if you are to take the equivalent of a and u, so what is the equivalent of our a squared? The equivalent of a squared is the constant, which is 9. Again, if you are to take the square root, so the equivalent of a is simply equal to 3. So what is the equivalent of our u squared? The equivalent of our u squared is equal to the x plus 4 quantity squared. Again, we are to take the square root. So the square root for both sides is simply equal to u, is now equal to x plus 4. If we are to take the first derivative, that is du, that is simply equal to the dx, which is simply our numerator. Then, okay, again, this is now in the form of the integral of the du divided by the square root of the a squared minus the u squared, which is equal to simply the arcsine, okay, the arcsine of u divided by a plus the constant c. So we are now ready to just substitute. That is equal to, we have arcsine. Okay, so again, what is the equivalent of our u? The equivalent of u is equal to the x plus 4. So we have that as x, okay, plus 4, then divided by what is our a. The equivalent of a is simply equal to 3. So divided by 3 plus c. So this will be our final answer for the third example. Okay, so let's try another example. So let's say evaluate the integral of dx. This is divided by 49 plus x squared. So if you are to observe this given, it matches the second formula. So we can have it as equal to or similar to the integral of du divided by the a squared plus the u squared. As you can see, the operation between the terms on our denominator is now addition. So basically, we'll be having the equivalent of a squared is now equal to 49. If we are to take the square root of 49, so the value of a is simply equal to 7. The equivalent of our u squared is equal to x squared. So again, if we are to take the square root, so our u is simply equal to x. And if we are to take the derivative, du is now equal to dx, which is simply our numerator. So we'll be having the equation, or the second equation, the integral of du divided by a squared plus u squared is equal to the 1 over a. This is arctan of u divided by a plus c. So all we have to do now is substitute. So we'll be having that as equal to, that is 1 over, again, what is the value of ours of 7, or the value of A is 7, and the value of U is simply X. So we have that as the 1 over 7 multiplied by arctan of U, which is X, divided by A, which is 7, plus the constant C. So this will be our final answer. Alright, the final answer for the, I think this is the fourth example. So we have that as 1 over 7 arctan of X over 7 plus C. Okay, so let's try another one. Alright, so let's say evaluate the integral of the dx. Okay, this is divided by x squared plus 6x plus 10. Okay, we have on the denominator we have 3 terms, and they are separated by addition operation. So we are to stick on the second formula. So all we have to do here is express our denominator into this form, the a squared plus the u squared. But the problem is that we cannot, this is not a perfect square. So what are the factors of 10? We say 2 and 5, but it will not sum up to 6. So let us again do algebraic manipulation. So let's say this is x squared plus 6x plus 10. So let us again do completing the square. So let us complete the square. So for the term x squared plus 6x, so again we'll just focus on the numerical coefficient of x. So what is the half of 6? The half of 6 is 3. If we are to square that one, that is simply equal to 9. So that is the same as x squared plus 6x plus 9. For us to have a perfect square. So but we have plus 10. If we add 9, we just subtract 9 from the constant. So that it's just the same that we are adding 0, and our original expression is still similar to this one. So that is the same as x squared plus 6x, then plus 9. Then what is 10 minus 1? That is simply 1. Then we are now to factor this square. So we have that as x plus, again, the half of 6 a while ago is 3 quantity squared plus 1. So take note that the x squared plus 6x plus 10 is still similar to this expression. So therefore we can rewrite our integrand. Okay, this is now equal to the integral of the dx divided by, we have x plus, that is x plus 3. Okay, x plus 3 squared plus 1, or we can rearrange it again. That is the integral of the dx divided by 1 plus the quantity x plus 3, a quantity squared. So from this expression, or from our integrand, the equivalent of a squared is simply equal to 1. So basically the square root of 1 is simply 1. Then we have the equivalent of our u is equal to u squared is equal to the quantity of x plus 3 squared. So if you are to take the square root of both sides, so the equivalent of our u is simply equal to equivalent of the u is simply equal to the x plus 3. If we are to derive, that is du is simply equal to the dx, which is simply our numerator. So now it satisfies the format of our second equation. Therefore, Okay, the equivalent of this integrand is the same as the integral of the du divided by the a squared plus the u squared, which is now equal to 1 over a multiplied by the arctan of the u over a plus the constant c. So all we have to do now is substitute. So that is 1 over, what is our a? That is simply 1. I multiplied by the arctan. Okay, arctan of u. Okay, what is our u? The value of u is simply equal to the x plus, that is x plus 3. Okay, x plus 3, then the value of a is simply 1, then plus c. So simplifying further, we have 1 over 1 is simply 1. Okay, then we have our final answer as the arctan of x plus 3 plus the constant c. So this will be our final answer for the fifth example.